12 astronauts recently began practicing for long-term manned missions into space. These missions will be unique. Unique because it will be the first time a large rocket stage is used, not only as a fuel carrier, but as an orbiting space station for astronauts. The actual rocket looks like this. It serves as the second stage when mated to the uprated Saturn booster. The stage remains in orbit after its initial job is finished. Later, a crew of astronauts meet and join the empty rocket. They will crawl inside the big hydrogen tank and set up living quarters, staying in space from 28 to 56 days or longer. To prepare themselves for missions like these, the 12 astronauts visiting Marshall inspected mock-ups of the orbital workshop and performed a variety of tasks. This is what it looked like inside as the astronauts became familiar with the living working area of the fuel tank. Entire sections of the interior were set up so that the men could practice. Some of the astronauts were strapped into zero-gravity simulators to better understand how it feels to perform while weightless. The orbital workshop is about the size of a 3-bedroom house. When put into operation, the crew will be able to move freely without special clothing or breathing equipment and conduct experiments ranging from Earth resources studies pertaining to the quantities and status of our air, water, minerals, animal, and marine life to solar astronomy observations to learn more about man's role in the long-term exploration of the universe. We asked Mr. Dale Myers, NASA's Director of Manned Spaceflight, to give us a status report on Skylab, the United States' first space station.
This year has been a big year for Skylab. All of the hardware for the program is coming into focus. Our qualification programs are underway. The major elements of the Skylab system are in the final positions of manufacturing and checkout. Now, one of the more important things to me about Skylab is it gives us an opportunity to learn more about man's capability to work and live in space.
Already, Skylab's major units, including the workshop, the airlock, the docking structure, the solar observatory, are in the final stages of manufacturing. The workshop, which will be both home and laboratory for 3 teams of astronauts and astronaut scientists, is in the final stages of manufacturing. Functional tests are giving us proof that crew compartments are ready for occupation in space. The final systems and scientific equipment are being installed. The workshop has been powered up for the first time. Overall, the workshop is moving steadily toward its integration with other units of Skylab. The airlock, which is both a passageway and a control and communication center, was essentially completed with manufacturing and factory checkout. The docking structure, or multiple docking adapter, which is both the entranceway to Skylab and an experiment station, was virtually finished. The adapter has been mated temporarily with the airlock to make certain the two fit together properly. Next, they will be separated, final equipment will be installed, and they will be rejoined, this time permanently. The final major unit, the Manned Solar Observatory, has been assembled at Marshall, and the equipment is being checked out. The flight unit itself will be tested both at Marshall and the Manned Spacecraft Center. It will then be flown to the launch site. It is there that all Skylab hardware will finally be combined and integrated. Apollo Command and Service Modules will be the transportation system for the astronauts. In essence, taxis for the round trip between Earth and Skylab. The first of these has already completed manufacturing and factory checkout. and the remaining craft are close behind. Saturn launch vehicles are starting to emerge from storage where they were placed earlier in Apollo. Virtually the same facilities used for Apollo operations will be used for Skylab. At the Kennedy Space Center, the Complex 39 facilities used to check out and launch lunar vehicles will be used for Skylab missions. A Saturn V will launch the Skylab into orbit. A special pedestal was built to permit the launch of Saturn 1B vehicles from Complex 39. Saturn 1Bs will launch the command and service module. At the Manned Spacecraft Center, Skylab flights will be directed from the same mission control facilities used throughout Apollo. At Marshall, the mission support facility used in Apollo will again be used in Skylab. In Skylab, our first scientific laboratory beyond Earth, we can conduct a whole new regime of experiments especially suited for space. One promising example is the opportunity to study the sun from a manned solar observatory in space, unhindered by the Earth's atmosphere. With the Skylab Solar Observatory, we can expand our knowledge about such things as relative abundances of chemical elements in the sun, generation and release of solar energy, relationships between phenomena of the sun and atmospheric and magnetic field events of Earth. Altogether, some 500 hours will be devoted to the solar studies, which will comprise the most complex scientific investigation ever undertaken in space. Another complex subject of study will be man himself. For all our experience in space, there are still major questions about how the human body and mind will respond to space flights lasting 4 to 8 weeks. In Skylab, for the first time, a physician and a specialized medical facility will be sent aloft to measure and evaluate man's ability to live and function in space.
We know we want to find out how man survives in space for long periods. We know there's a lot of jobs that can be done in Earth orbit to help man on Earth. And what we've done is taken mostly Apollo hardware, modified it as best we could, and with it we've come up with really a very exceptional space station that we hope is going to answer many questions that need to be answered now for the future of spaceflight and also the future of how we're going to use space to help the man in the streets.
Yet another important scientific undertaking is the one for developing and evaluating instruments for studying the Earth from space. Part of a broader program to advance techniques for gathering information, the Skylab studies will make a substantial contribution toward the fullest and most intelligent use of our planet and its limited resources.
We know that pollution is not just a problem in a small scale. Pollution that's in Los Angeles today will be in Phoenix day after tomorrow. It'll be in Dallas, Texas, the day after that. So what we hope to do is look down at the Earth with suitable sensors, let's say infrared sensors, microwave sensors, various other frequency bands, including just visual cameras, and with this equipment, look at the Earth. Take this information, bring it back, and evaluate it using different electronic and photographic techniques, and from this data, hopefully be able to look at crops and tell whether they're diseased or not, look at some and see if they need irrigation, look at some of the forests that we don't normally get close to and see how they're doing, try to get a yield of, for example, the grass on rangeland, determine the runoff that's going to happen due to spring thaws from the snows on the mountains, find fish in the ocean, many things. We don't really know exactly all the things we can do right now with Earth resources because it's in its infancy.
Among the dozens of other investigations planned are studies, both national and international, in materials technology, biology, physics, and astronomy.
Well, Skylab's going to be America's first space station as such. We're going to be up there roughly 8 months, and we're going to visit it 3 times during this 8 months. It will launch at the end of April of 1973. The very next day, we'll send up a crew of 3 men that'll occupy Skylab for a month. Well, 28 days, really. They'll return to Earth, and then about 2 months later, the second crew will go up, and that's the crew that I happen to be on, Skylab 3 mission. We'll stay there 56 days or roughly 2 months. We'll return to Earth, and then the third crew will go up about a month later. So essentially we're going to occupy it a total of 5 months out of 8 months, beginning the middle of 1973. That's not very far away from right now.
Flight crew training programs are in full motion. Mission simulators have been received and installed at the Manned Spacecraft Center. Skylab astronauts are familiarizing themselves with the hardware, for instance, biomedical and crew equipment. They are working with equipment in the weightless conditions which can be induced by aircraft flying roller coaster-like arcs. They are studying and evaluating equipment and operations underwater, a condition which in some ways approximates actual weightlessness. In addition to other preparations, each flight crew member will spend a minimum of 1,500 to 2,000 hours training expressly for his role in Skylab. Altogether, the 3 Skylab flight crews will spend almost 5 months in orbit about the Earth, carrying out more than 50 investigations for science and technology. The flight crews have been announced. The first, Charles Conrad, Joseph Kerwin, and Paul Weitz.
To have a guy there to change film, to change programs, to repoint the thing, to fix it when it breaks, to take it out and put a new one in, is in many cases not only the rewarding thing to do, but it's the cheap thing to do.
Of course, Apollo went on to take us to the moon, but it also left us with a tremendous technology to look towards the future. And as far as Skylab is concerned, it represents a definite turning point.
I think it's a natural question is why explore space? And some people have different views on this. Personally, to my way of thinking, part of human nature is to reach out and explore.
We're right on the threshold of really a brand new opportunity to explore the solar system and the universe and to increase the value of benefits back here on home.
If our children and our children's children are going to enjoy the same quality of life here on Earth as we have enjoyed in the past, we're going to have to learn how to find new resources and how to manage the ones that we have more efficiently and more effectively.
And of course, space exploration provides this spiritual quality. It allows you to go to the unknown and find what's there, and hopefully by doing so, you're going to improve your lot.
The fact of the matter is, if man stops really stretching himself and extending himself and looking out, then I think that's when civilization will begin to decline. Man just has that inquisitive nature, and it's got to be satisfied.
First, we've explored the moon, and we're now going to explore near space, and finally, we're going to explore the solar system. All of this, man plays an integral part.
Spacelab itself, as it is presently conceived, will provide us with a capability which grows on Skylab, expands on Skylab, and provides us with an enormous capability to conduct research in space.
Skylab was the first manned spaceflight program to have a rescue capability. It called for 2 astronauts to fly a 5-seat spacecraft into Earth orbit, rescue the stranded crew, and return to Earth.
The unmanned orbital workshop was launched in May of 1973 atop a Saturn V rocket from Pad A at Kennedy Space Center in Florida.
Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. And we have a liftoff. The Skylab lifting off the pad now, moving up. Skylab has cleared the tower.
Houston is now controlling. 18 seconds, pitch and roll program started. Saturn now maneuvering to its proper flight path attitude. Mark, 25 seconds. Seconds. 35 seconds, 1 nautical mile in altitude, looking good. Range safety, give Saturn a green, we've cleared the beach. Seconds, 2.5 nautical miles in altitude. Ground display data shows good stable thrust on all 5 engines. Coming up now in 1 minute. Mark, 1 minute.
Of course, as soon as we could listen in on the flight director net, we realized something had happened to the lab, even though it looked like a perfect launch from where we had been observing it. The meteoroid shield ripped off about 60 seconds into the flight, and with the meteoroid shield gone, this gave us the problem of overheating in the workshop, so many different ideas in the intervening 10 days were put out as different means of being able to rig a temporary heat shield or a permanent heat shield which would allow us to salvage the vehicle.
This is Skylab Control. Here in the control center, the problems associated with the failure of the Saturn workshop solar panels to deploy are being discussed at some length by management and flight controllers. Preliminary telemetry indications are that there could have been a malfunction with one solar array beam fairing and the meteoroid shield, which could have led to subsequent anomalies.
It was felt that the meteoroid shield had been completely lost at deployment, which accounted for the high heat levels. Also, that fragments of the meteoroid shield had jammed or otherwise hindered full deployment of the solar array panels. Failure of these panels, which were designed to furnish about half of Skylab's electrical power, meant that the total power burden would have to be borne by solar panels of the Apollo telescope mount. By early evening, workshop temperatures had risen above the level of safety. Launching of the crew the following day received an indefinite hold, pending satisfactory solutions.
The next 10 days were hectic. Immediately, teams were formed to provide answers to the problems. A major objective was to design and fabricate a thermal shield that could be deployed on the workshop to make Skylab habitable.
It had good functional reliability, and the crew would be able to deploy it from inside the workshop through a scientific airlock. Another shield, the twin-pole sunshade, would also be carried on the mission as a backup.
In conditions approximating 0G, they also trained underwater in methods of freeing the jammed solar panel.
Simulation methods were mostly inconclusive. Little was known about the extent of wing damage at this point, and the crew could only speculate on how best to make them deploy.
In the underwater simulation, we then wanted to demonstrate 3 different capabilities. We wanted to show that we could pry the strap off using a cinch bar or a pinch bar that we had on board the spacecraft already, and we demonstrated that capability. The next thing we demonstrated was the capability to cut through the strap using a very small device that's stowed in the onboard dental kit called a bone saw. And this bone saw fits very nicely on the thumbs of the glove, and you slip it underneath the aluminum strap and then just cut through it with a back and forth motion. So we demonstrated that, and then finally we demonstrated that just by tightening up further on the cutters, the large cutters that we had at the end of the 25-foot pole, that we could also cut through the strap using those cutters.
The actual work would have to wait on an eyewitness assessment by the astronauts in space. Time was becoming critical if Skylab was to be saved. Relief would come only from the thermal shield Parasol, which would be deployed by the astronauts when they arrived at Skylab. During the early morning hours of May 25th, almost 10 days after the original schedule, a Saturn 1B was ready to launch an Apollo spacecraft for the first manned visit to the Skylab orbital workshop.
This all-Navy crew consisted of Captain Charles Pete Conrad, Skylab commander, a veteran of both the Gemini and Apollo programs. Commander Paul Weitz, who would be Skylab pilot for the mission, had been a member of the support crew of Apollo 12. And Commander Joseph Kerwin, scientist pilot, who would be the first American physician in space.
We actually launched on the 25th of May with 3 potential ways of covering the workshop to shade it from the sun.
The 10-day delay had been a giant cram course for all concerned, especially for the crew. The execution of all the planning effort was now solely in their hands.
2, 1, 0. We have launch commit and we have liftoff. The clock is running and Skylab has cleared the tower.
Tower in Houston, Skylab 2. We fix anything. We got a pitch and a roll program.
The thrust is going all engines.
Boy, is that a smooth ride.
By mid-afternoon, the crew had overtaken the workshop.
TV picture beginning to come in now to the control center.
Skylab Houston, we're AOS at Guam for the next 10 minutes.
Callie, the Skylab. We got her in daylight at 1.5 miles, 29 feet per second.
Roger, Pete, copy.
They effected rendezvous and performed a Flyaround to assess the damage. Most predictions were confirmed.
Okay, Houston, the meteoroid shield area is solid gold.
Roger, copy.
Your brief description is you suspected solar wing 2, right? 2 is gone. Completely off the bird. Solar wing 1 is in fact partially deployed, and the reason that you've got different readings not symmetric between your 3 solar panels is there's a bulge of meteorite shield underneath it in the middle, and it looks to be holding it down.
Roger, copy.
Okay, Houston, it looks like the meteorite shield at the upper vent panel on the SAS wing has wrapped around it just slightly. Where are we? Now, my guess is that our easiest thing to do is just go to the end and try and deploy it.
Roger, Pete, from which side of the SAS is the meteoroid shield slightly wrapped around? Is it on the side of the main tunnel? Or
Before docking, the crew attempted to free the wing.
The other side, Dick.
Although the try was unsuccessful, the TV pictures seen here proved invaluable in devising the technique that ultimately worked.
We've seen enough television to let us think a lot about this. You're cleared to turn off the TV and complete any photography you haven't gotten, and you're cleared for soft dock.
About 7.5 hours after liftoff, as we were rendezvousing with the workshop, the extent of the damage became apparent to us very rapidly. We first confirmed that the one solar wing had completely left the vehicle and was no longer around. We could see the damaged wires at the hinge line. And, of course, all the gold foil, which normally would have been underneath the heat shield and meteoroid shield, was exposed to the sunlight, and it had darkened on the sun side considerably. Then as we got around to the side where the jammed solar wing was, it became immediately obvious to us that this little tiny metal strap that had torn off the heat shield and meteoroid shield had jammed the solar wing.
An unsuccessful attempt was made by Weitz at freeing the panel, working in the open hatch of the command module before docking with the workshop.
Stand by for the first call from spacecraft communicator to the crew of Skylab 2.
Skylab Houston through the Vanguard. How do you read?
Got a hard dock out of it.
Hey, way to go.
We got a tunnel integrity check into work right now.
Following a night's sleep in the command module, the crew spent the morning of Saturday, the 26th, activating and checking systems in the multiple docking adapter and airlock module.
Later, they were given a go to enter the workshop.
So we are progressing slow but sure, and everything so far is working.
Well, the advantages which manned spaceflight offers are in the area of repair and maintenance, which we've demonstrated time and time again on Skylab. As a matter of fact, the whole Skylab series of flights would have been a failure had it not been for the ability of the first crew to repair the space station.
Pete and I went down into the workshop, installed the canister that contained the Parasol in the scientific airlock.
Okay, Pete, we had a little dropout there, some noise. Could you tell us what step you're on?
We're about to put rod delta on.
Roger, copy.
Okay, we had no trouble venting it down. It vented in about 4 minutes, and it held zero for 10 minutes without any outgassing. Door opened very smoothly, and so far the rod extension has gone very easily, and as I say, we're just taking a little heat break.
Some 4 hours after the operation began, the thermal parasol was deployed.
Joe was observing the deployment of the Parasol from the command module.
I couldn't see the airlock itself, but I could see this funny-looking orange thing, all rolled up and skinny, come pooching out of there. And then Pete said, okay, we're going to let her go. And it just started to unfold and did a lot of flopping, and it kind of settled halfway folded and halfway unfolded.
We deployed it as best we could, pulled it back down to us about a foot off, and that was it. It worked quite well for the rest of the mission. I think on about day 4 or 5, we definitely knew that it was no longer an uncomfortable environment. It was warm, but certainly nothing that you couldn't put up with.
In mission control, optimism that the mission would be saved wasn't long in coming, as external skin temperatures began dropping rapidly, and within the workshop, too, they had started to fall. The Parasol was doing its job, but there was still a shortage of electrical power.
The crew put in a long, trying day activating the workshop. Getting things organized and in the proper place was a chore in itself. However, they were discovering to their satisfaction that moving big pieces of gear presented no problem in the weightless environment. By noon, Monday the 28th, with the workshop completely activated, primary emphasis was on getting the biomedical experiment started. This was the first in a series of lower body negative pressure and vector cardiogram experiments. Paul Weitz, the subject, Joe Kerwin, the observer.
This lower body negative pressure test provided valuable information on the cardiovascular system, carefully checked and monitored on the control panel, which supported all medical experiments.
There followed a workout on the bicycle ergometer to check metabolic effectiveness and to evaluate the bicycle as an exerciser for long-duration missions.
Ideally, the handlebars would be longer than they are now and would kind of sweep down around you so you could grab them in the right place.
The astronauts were instructed to exercise frequently, and one of the techniques was the ergometer, or bike, to help keep them in shape. This also served as a test for possible changes in metabolic activity while working and living in a zero-G environment, as well as a check on heart rate and blood pressure under these workloads.
There was another major dynamic test or stress test that we used to determine our condition in flight, and that was the bicycle ergometer. You simply worked your heart, your muscles, and your lungs to the maximum capacity to see whether they all played together the same way in the absence of gravity. We found that our ability to exercise, our heart's ability to move blood around the body, the cells and muscles' ability to extract oxygen from it, and all the processes that go into a maximum exercise were completely unaffected by zero gravity.
Other medical experiments conducted over the next few days included blood samplings from each crew member to satisfy the 5 blood study experiments, body mass measurement to determine each crewman's daily weight and to validate the use of this device for weighing in zero-G, a rotating litter chair, a part of the human vestibular function experiment, tested for motion sickness, rotation perception, and ability to determine orientation.
Medical experiments were perhaps one of the most important things we did during the whole Skylab mission. We attempted to take a look at man as he reacted under long-term weightlessness. Whether or not we can extrapolate that out to several hundred days, incidentally, it takes something like 400 days for a typical Mars mission, we don't know right now. But it does indicate that we're on the right way to, in assuming that man can exist for long times at zero-G.
In addition to these and other medical experiments, science experiments were simultaneously being performed. Here, Pete Conrad operates the Apollo telescope mount control and display panel in preparation for the solar physics studies. In subsequent operations, data such as this active region of the sun was recorded by the telescope.
Got a tape motion light.
The Earth resources experiments also got underway after activation of the 6 remote sensing systems.
Mark, S-192, I got a ready light. We just came out from over the clouds. How about that? Auto sequence start on 90 and you EPC go.
From a broad field of view provided by this large space platform, the systems began photographing selected portions of the Earth's surface in the visible and near-infrared spectral regions. Although the crew had earlier encountered a number of equipment problems, the result of excessive temperatures, the prospects now looked bright for a full 28-day mission. The temperature had stabilized in the mid-70s. The food was good, and so was morale. And up to now, the 4,700 watts of available power appeared to be adequate as long as high-load experiments were staggered. However, by the 5th day, some of the storage batteries had begun to perform in a degraded manner. The power shortage grew critical, and it became apparent that to carry out the mission, the jammed solar panel would have to be deployed. Meanwhile, at Marshall, in the underwater simulator, techniques were being developed based on TV coverage of the solar wing. Using only tools and equipment like those aboard Skylab, the backup crew developed a set of procedures they felt would do the job.
Astronauts Conrad and Kerwin went on their first spacewalk to repair the damage. This took 3.5 hours, and it was difficult work.
Just take your time. Okay, Houston, we're out there. We have the debris in sight. There looks like enough room to get the cutter, and I'm trying to help Joe stabilize.
As the simulations had shown, access to the solar wing was the big problem, what with few handholds or foot restraints. It was solved by joining pole sections of the twin-pole sunshade, anchoring it by hooking a pair of cutters onto the strap that held the wing. Thus, a temporary handrail was fashioned that allowed Pete Conrad access to the solar wing, where he attached a tether. The cutters then severed the strap, and the tether was pulled taut to free the wing actuator.
Of course, not having gotten the wing out on our first attempt when we came up there, we really had about half of the electrical capability that we should have had. So it was very, very important to attempt to get that jammed solar panel out. So Joe tried, and then we decided to tighten it up again, and I'd try, and I got under it, and boy, it broke. It let go in one big hurry, and there I was, launched into space again, free-floating, hanging on the end of this string. And, well, by the time I got straightened out again and looked around, why, there it was, out and deployed.
Hey, there you go. Let go, let go. All right. I've got it.
After the crew returned to Skylab, an attitude change placed the solar array system into the sun. Within hours, the electrical power surged to almost double the previous level, and the original flight plan could be resumed. In the days that followed, the nagging problems that had plagued the astronauts from the start began to resolve. Experiments were coming off like clockwork, and a wealth of scientific data was being gathered. Experiments such as this one in materials processing.
Many space processing experiments were performed aboard Skylab in a vacuum chamber and heat treating apparatus, including an electron beam gun and small electric furnace. The formation of crystals might well be the most valuable of all the manufacturing experiments.
The weightless condition simplified sleep accommodations. Since there was really no up or down, the only requirement was a sleeping bag type of restraint. And as mentioned earlier, heavy objects were easily handled. It was the small pieces that sometimes got away. But even when objects were lost, they generally turned up sooner or later on the air conditioning screen, there to be reclaimed.
Weightlessness can be lots of fun, too, as Pete Conrad shows as he exercises, much like a squirrel in a cage. No circus acrobat or Olympic swimmer can match this.
I guess our most significant accomplishment from the point of view of where we started this mission on May the 15th was that we have now, I would say, a 90% up operating space station to turn over to the SL3 crew, and probably even more significant in my mind, and also to go along with what the doctor said, but I'll have to wait until the people on the ground look at our physical data. I believe that man has once again proven that he can operate efficiently, well, and happily in space in the operation of a space station. And only time will tell the exact scientific return from the experiments that we've performed.
On day 29, after performing final closeout of the orbital workshop, the crew donned spacesuits for the return leg of their mission.
Skylab Houston, we're in at-hold CMG. Your go for undocking.
Okay, stand by.
Roger.
Okay, we're free. We got 0.4 of a foot per second, Houston.
Roger.
Bye-bye, Skylab.
Skylab Houston, we're AOS again at Texas, and we got you for the next 12 minutes, and we got a picture.
After undocking, they remained on station briefly to obtain photographic coverage.
Skylab Houston, everybody around here has looked at the bird, and it looks real good. Your go for SPS-2 deorbit and entry. There's an Orion out there that will be talking to you after the blackout, so we'll see you there. Have fun.
Roger, roger.
Following deorbit, the command module, its heat shield trailing a fiery plume, re-entered the atmosphere. For the first time in about a month, the crew experienced the forces of gravity.
Ticonderoga standing by for sonic boom now.
Skylab Houston through Orion 1. How do you read?
Roger, we read you loud and clear, Houston. Everything's okay. We're out of 40,000.
Very good, Pete. You're in the groove.
Hello, recovery, Skylab. On the mains, everything's okay. Skylab, this is recovery. How you doing up there, over? Recovery, Skylab. How do you read? This is recovery. Loud and clear. How you doing? Roger, we're in 3 good mains. Roger, you looking good from here? We're about 3 miles to the northwest here. Okay, we're out of 4,500 feet. Everything's good. Recovery, this is Ticonderoga. Request you carry Skylab for computer readout. This is recovery. Roger, Skylab, can you give us a computer readout, over? Skylab, say again. Roger, do you have a computer readout, over? Yes, sir. 24.78. 137.06. Ticonderoga. Ticonderoga, Roger, out.
Recovery, we have a visual below the overcast, about 100 at 050, 6 miles from Tycoon Road. Recovery, splashdown, and it looks like stable 1. Roger, out.
Splash time 13:49:48 Greenwich Mean Time.
Hello, Recovery Skylab, do you read? Recovery, read you loud and clear. How's it going? Okay, everybody's in super shape. That's great. Welcome back. Thank you. That's an EOS team is deployed. Back on the road as you read Skylab over. Recovery, Ticonderoga, request to repeat, over. Roger, Skylab reports everyone's in super shape, over.
This is Skylab Control. Here in the Mission Control Center, cigars are being lit, a lot of hands being shaken, backs being patted. On the big forward screen, a replica of the Skylab crew patch, and these words, Skylab 1/2, mission accomplished, a tribute to the combined abilities of NASA and all support contractors who surmounted problems to begin a new era of scientific achievement.
To be a 15 or 20-minute interlude isn't going to be at all. Eldridge opened the command module hatch. Out comes Pete Conrad, commander of Skylab 2, back from a successful 28 days in space, and the band of the Ticonderoga strikes up, anchors away, saluting these 3 American astronauts, all naval officers.
Almost all of the original objectives of the 28-day mission were achieved. All medical experiments were conducted. 80% of the planned solar studies were carried out. 11 of the 14 Earth resources experiments planned for this first mission were carried out. Information about 31 states and 6 foreign countries was obtained for 75 of the program's scientific investigators. One of the primary questions Skylab sought to answer by the end of its 8-month investigation was how effectively can man perform work in space? A clear answer came earlier than planned in the first Skylab crew's repair efforts, which made continuation of the manned missions possible. And there was renewed optimism that Skylab's 3 full missions would be completed as scheduled.